Right, good morning class. At this point in our lives we are busy with Euclidean geometry. Yeah. Exciting. You guys had some homework, of course. The homework was exercise 9.1, the even numbers, correct? We passed that. Nice. So we're on 9.2, even numbers. No. It was 9.2, the odd numbers. 9.2 even or odd? Odd. Was it the whole exercise? Oh, sorry. I'm sorry, man. Why are you getting so upset? Okay, 9.2, page 283 out of the Keeping Maths Simple textbook. That's the textbook we're using at this point. We are told that O is the center of the circle in each diagram. Determine the value of the variables in each case. Show all your working and give you a reason for each step. Very important here. I'm not going to answer the whole exercise. Okay. The first part of the lesson I'm going to answer the questions I've selected, which is every alternate sum or the odd numbers in the exercise. If you have a problem with the sums that wasn't done on the board, then you can ask it at the end of towards the end of the lesson, okay? Or after we've done with this. Alright, is that okay? Alright, so let's start. So in 9.2, 1a, what is a equal to? As you can see, angle at center is twice angle circumference. So a is going to be 64 degrees. Why? Angle at center equals 2 times angle at circumference. Do you all agree with that? Okay, let's go to the next one. C. As you can see here, angle at center is twice angle at circumference. Okay, so D is equal to half of 110, which is 55 degrees. Why? Angle at center equals 2 times angle at circumference. Okay, so there goes 55 degrees. However, if you look at C, C is also subtended by this arc here, not so. So C is going to be a half of 110 as well. Can you see that, people? So C is equal to 55 degrees. Why? Angle at center equals 2 times angle at circumference. Okay. Any confusion there? Alright. The next one. Don't forget, I must give you a scope for today for next week's paper. No? You know you're writing maths first. Yes, so make sure about that. So you only study for the first paper normally. Right? So you made maths first for you guys. People, let's look at E. What can be worked out first? F. Not so. So F is what? F is double 120. Not so? So angle at center is twice angle at circumference. So F is 240 degrees. Why? Angle at center equals 2 times angle at circumference. Okay, so 240 here. How do you work out G? Angles around a point, the revolution, not so. So it's going to be 360 minus 240, which is 120. And the reason is it's a revolution. So it goes 120. What do you notice here? If I'm not done with the diagram, I start populating the diagram. I start writing these things on the diagram. Also in your exam, you'll get an answer sheet. No? Whatever writing or any scratch on the diagram you want to do, rather do it on your answer sheet. Okay, sometimes you get marks on your answer sheet as well. Okay, especially if you're not formulating your work properly. Okay. Well, H, how do you work out H? We know angle at center is twice angle at circumference. So H is going to be 60 degrees. Why? Angle at center equals 2 times angle at circumference. Okay. The next one. Is there any confusion there, people? No. Okay. The next one, we can calculate M. How are you going to calculate M? Again, angle at center is twice angle at circumference. Can you see that, people? There is a M is equal to 2 times 50, which is 100 degrees. Why? Angle at center equals 2 times angle at circumference. Okay, it's 100 degrees. How are you going to calculate N? Firstly, we know that and that is your radii. Not so. So this angle here will be equal to N. So we're using the fact that it's angles opposite equal sides, radii. Okay? Then what we're going to do? Sum of triangles. So we say 2n plus 100 equals 180. What's the first thing we said? We use angles opposite equal sides. And that is your radius. And what else did we use? Interior angles of a triangle. So we use sum of triangles. Okay. We must take all the theorems that is being used here. So we take that over. So 2n is equal to 180 minus 100, which is 80. Divided by 2, of course, is going to give you 40. Okay. Yes. Sorry? Your answer is right and the reason is wrong. Then at times you get a reason mark and statement mark. Then you get the mark for statement, you won't get the mark for reason. Sometimes you get statement and reason mark. You must have both right to get the one mark. You're going to do so. Sorry? Half. We don't work with halves, Michael. We're not in Zimbabwe. No? Other countries I know work with halves. Saudi, they also work with halves. They're tutoring somebody overseas. But yeah, we don't work with halves. No? So, get it right. Know what you are doing. Okay? Will you guys understand? Also, when we're introducing a theorem, start getting it right from the offset, from the beginning. Why? Because when it becomes more complex, these little things are sorted out to do. Okay? People, 9.2, it's on page 283. What do we know here? Angle at center is twice angle at circumference. So 3x minus 62 is equal to 2 times x. Angle at center equals 2 times angle at circumference. Okay. So you solve for x here. 62 goes that way. So x is then equal to 62. Any confusion thus far? No. So I've chosen number 3. As we know, we're going to do the odd numbers. Okay. Given BOA is the diameter of the circle center, then we are told that A, C, and B are points on the circumference of the circle. As I told you before, for these theorems to work, I don't think I told you or the other class, for these theorems to work, it's either the points must touch the circumference of the circle, right? Or it must also start from the center or go through the center. Otherwise, if you draw a triangle inside here, inside the circle, and it's not touching the circumference of the circle, then that means nothing to us. It is not in circle geometry, then it's Euclid, it's some other part of geometry. You guys understand? So that's why they always say the points are on the circumference of the circle. So that you know that Euclidean geometry or circle geometry theorems can be applied. You understand? So our point circumference of the surface. Then we are told that OC is drawn. O1. Okay, so this is the center. What do we know? What do we know if that is the center? If that's the center, what do we know? BO is equal to OC equal to OA. All those names say. Why? Radial. Then we are told that O1 is 96. O1 is 96 degrees. Calculate the size of A1. So what is angle A1 equal to? Half of 96. Why? So angle at center is twice angle circumference. Can you see this BC, this arc BC? This arc is subtending angle at center and angle at circumference. Can you see that, people? I see you use your fingers, no? Play little games with yourselves. From this arc here, BC, to the center, the same arc subtending an angle circumference known as angle AB. You guys understand? So, that is 96. Angle A is half of that. So, angle A is going to be 96 divided by 2, which is, 48. Reason? Angle at center equals 2 times angle at circumference. Okay, that is 48 degrees. So how do we calculate B? B, which is angle B. Angle B is the same as which angle? Angle C. You all agree with that? Right, nice. Is that B and that C the same? No. Can I just say angle C? No. There's more than one angle at that C. So I must name it properly. Okay? Since there's only an angle at B, one angle, so I can just say angle B. But since you are referring to this angle here, okay? So we're going to say that B, angle B is equal to OCB. So to name this angle is either OCB or BCO. Either way. Okay, Unela? Did I get it right? Alright, you guys understand? And what's the reason here? Angles, opposite, equal sides. And what sides are we referring to here? It's your radius. Not so? So this will simply be angle B plus angle OCB or BCO plus 96 equals 180. Not so? But since I want to calculate angle B and I want to have one unknown, so twice angle B plus 96 is equal to 180. Reason? Sum of triangles. And it's in triangle BOC. So angle B is equal to 180 minus 96 divided by 2. It's going to give you 42 degrees. You guys get that? Huh? You got that? Right? So that is going to... And also look, what am I doing? I'm populating my diagram. I'm writing, sorry, 42. I'm writing my values into the diagram. Okay. Then they want you to work out O2. I'm going to calculate angle O2. Angles on a straight line. These O2, so it's angles on a straight line. So 96 plus angle O2 is equal to 180. Your straight line. So angle O2 is equal to, sorry? 84 degrees. Okay. Any issues here? No? And that's it? Alright. People, any other questions with regards to this work? That's page 283. Page 283. People, any other problems with this work? No. So you guys managed to do number 2 and 4. No? People, Theorem 3a. I want you to write this down. Theorem 3a. Page 284. Quickly, no? So I want to do a couple of examples on this now. You guys finish? Yes? Right the next one down. The converse of the theorem. I'll explain that to you now. Okay, I'm just going to pause the video. Okay, so we are told in 3a, in Theorem 3a, okay, just one step back quickly. Okay, if you've got this, okay, you got the circle, and this was 170 degrees, okay, doesn't look like 170, but the circle, and you got 160 degrees. What's the size of this angle here? What would the size of that angle be? 80 degrees. Why? Angle of center is twice angle of circumference. So what if I had made that angle be 180 degrees? And what would that angle would have been now? 90. Not so. Why? Because the angle at center is twice angle of circumference. Not so. But what do you notice about this? This is actually, what type of circle is this? Semicircle. So we now pull that angles in semicircle. You guys understand where it's coming from? So your diameter will subtend 90 degrees at the circumference. Okay. So we are told in 3a, the angle subtended by the diameter. The diameter is that there. At the circumference of a circle is a right angle. Okay. If AB is a diameter, then angle C is 90 degrees. The reason for this theorem, angle in semicircle. Okay, so which means to say, you got this here. Diameter This PQR. If that is the case, then angle R is 90 degrees. Reason? Angle in semicircle. That's going to be the reason. Okay? You all okay with that? And the converse, what does converse mean? The reverse of the theorem. Okay? Converse is the reverse. Nothing to do with the techies. Theorem 3b. Converse of theorem 3a is the reverse of theorem 3a. If a chord subtends 90 degrees, an angle of 90 degrees at the circumference of the circle, then the chord is the diameter. We are told if C is 90, then AB is the diameter. The reason for this theorem is going to be chord subtends 90 degrees. Let's put that in layman's terms, easy words there. You've got a circle and a chord. But this chord, remember what's a chord? A chord is a line which is going from one point circumference to the other point. Okay? That is the case. Then that chord and this chord subtends 90 degrees. So 90 degrees. No? Remember that's inside the circle. You got M, N, O. Then you have to conclude then that M, N is a diameter. Why? Why is A the diameter? Because chord subtends 90 degrees. You understand? So if you are given a diameter and the diameter subtends an angle at circumference, that angle is 90, angle in semicircle. If an angle of 90 degrees, if a chord subtends an angle of 90 degrees at circumference, then that chord has to be a diameter. Make sense? So let's put that into the plane. Okay. Let's look at an example. This example on page 285. We are told that XOZ is the diameter of the circle. And this is how you should approach these. Sorry? This is how you should approach these questions. You read through it, whatever you have discovered, you write it on your diagram. So we are told that ZOX is your diameter. So if that's your diameter, what do we know? That W1 and 2 is going to be 90 degrees. Why? Angle in semicircle. Also, angle Y is also 90 degrees. Angle in semicircle. Not so? Right. W and Y are two further points on the circumference of the circle. WX, WZ, YZ, the XY, and WO are drawn. O2 is 68 degrees. So if this is your angle at center, there's your twice your angle at circumference. Can you see that, people? So when you see the center, think of center. Angle at center is twice its circumference. Can you see that, people? Alright. Then we are told that x2, so let us put 68 in. x2 is going to be 42 degrees. Right, first question. First question, they want to know the size of x1. So how are you going to work out x1? Sorry? Divide 68 by 2. Why is he dividing by 68 by 2? Angle at center is twice answer. So do that quickly. Okay. So that is going to be half of 68 is 34 degrees. Why? Angle at center equals 2 times angle at circumference. Okay. So there we go, 34. What do you notice? Populating the diagram. I'm putting whatever I've determined onto the diagram. Why? So that's not the last question I got. Okay. Well, let's look at B. Z1. How can you calculate Z1? Z1 is also equal to which angle? The W2. Why? Angles opposite equal sides. Radii. Not so? And then you go with interior angles of a triangle. Can you guys do that quickly? Alright, so do that. So what do you guys get for Z1? So busy. What do you guys get for Z1? 36. 56. You all got 56? So you guys went to saying that Z1 is equal to W2 and it's opposite equal sides. Then you said twice Z1 plus 68 is equal to 180, sum of triangles. And then you divide by 2. There's another way I could have done it. Is this not 90 degrees? Yes. So I'm going to say that X WZ is equal to 90 degrees. Why? Angle in semicircle, not so? So that's 90 degrees. Remember, whatever is not on the diagram, I must state it. So what do I have here now? Again, a sum of triangles. So I can say 34 degrees, what's it, 34? Yeah, 34 degrees plus 90 degrees plus Z1 is equal to 180. Why? Sum of triangles, and it's triangle WXZ. So angle Z1 is equal to 180 minus 90 minus 34, which is going to give you an angle of 56 degrees, which is the same angle you guys got there. Not so? Then it says calculate Z2. Angle Z2. Here's Z2. Are you going to calculate Z2 now? 42. She says 42. Are those lengths equal? No, it's not coming from the center. It's not your radius. No. Angle Y is equal to 90. Why is angle Y 90? Angle in semicircle. Do I have to state it first? Why not? Not on the diagram. So when you got Y, you can then go with sum of triangles. So do that quickly. Girlfriend in front, yeah? You okay? What's wrong? Too much circles. What's wrong? You want to go home? What's wrong? Pains. Take it easy. Right? Maybe it's too much circles. It's getting you crazy. Right, let's cover this quickly. What can we say first? We said y equals 90 degrees. Y? Angle in semicircle. Okay. Then Z2 equals, no, Z2 equals 180 minus 90 minus 40. Why? Sum of triangles, and it's triangle XZ1. You okay with that? Or you could have said Z2 plus 90 plus 42 equals 180. So Z2 works out to be what? 48 degrees. We will sum like this is worth 1, 2, 3, 4, 5, 6, 7, 8. So probably 10 marks. No? I mean, you could get a maximum of 10 marks. But I would give probably 1, 2, 3, 4, 5, 6, 7. Because there is things that are repeated twice, like this. You use that theorem twice. Can you see that? That is, now I'll give you one, and in the second time I'll give you one for statement analysis. Like that. Okay. Not because I want to rob you, no. Because there's so much I want to ask you. You understand? Yes. Alright. Sorry? So now, I want you guys to start with exercise 9.3, the odd numbers. Okay, we'll probably answer one or two of these questions. My plan is to answer one or two before the end of this lesson. Okay, and you guys will be tested up until this theorem. Or you want theorem 4 as well? No. Don't be boring. Okay, so you're going to start with your homework now. I'm going to give you a scope for the exam. Somebody must type it neatly in the group for us. Pause the video at this point. Alright, so at this point you guys have done the first three odd numbers, no? Only one or only all three? Come people. Only the first one. Okay. So did you get the first one? So what can we say here? We are told that AB is the diameter. If AB is the diameter, what do we know? Angle C is 90 degrees. Diameter of the circle, center. Angle A is 27 degrees. Calculate the size of B, angle B. So firstly, angle C is equal to 90 degrees. Why? Angle in semicircle. So angle B is equal to 180 minus 90 minus 27. Why? Sum of triangles. And it's triangle. What triangle is this? ABC. Or ACB or BCA, whatever. Do I have to name the triangle I'm working with? No, you don't have to. You won't be penalized if you don't. But it will be nice if you do. Okay. So it's going to be 180 minus 90, 90. Minus 27 is 63. Who got this wrong? You have a lot of marks at stake. Huh? Don't. Yes. Sorry? Sorry? How many marks? 4 marks. You get 1 here, 1 there, 1 for getting B out, and 1 for that reason. Now you see, some people will give you a statement, reason marking, then you're going to get 3. But if it's the first sum in the exam with that theorem, then I normally give 2 marks. If the question is repeated, or the theorem can be repeated, then I'd give you only 1 statement, reason mark. Okay. You guys finished number 3 as well? Who's finished with number 3? Only a micronation? Right, so we'll give everybody else a chance. Okay. You guys finished? Huh? Who's finished? Oh my. People, listen. It's very difficult to teach a class that doesn't speak back to me. Okay? Then I don't know what you are busy with, what you have done, and so on. So if you're not finished, you just say you're not finished, or you're stuck, or whatever. Can I answer? You're stuck. So I can answer the question. So now, there we go. It's frustrating if you I ask you a question, you go, or you don't say anything at all. It's even worse. Okay. Right. Given L, M, N, and P are points in circumference of the circle. Center O, circle of O. So if that is the case, then what do we know? You say that's a center. We know that that is equal to that. It's equal to that. Not so. Why? Radii. And if that's a center, what else do we know? Okay, so we are told that LON is a diameter. So if that's a diameter, what do we know then? The whole angle M is 90 and P is 90. You understand? Then we are told that O2 is 70 degrees. O2 is 70. Alright? L2 is 25. Calculate the size of angle N1. So I'm going to calculate N1. N1 is equal to what? I'm going to calculate N1. N1 and M2 is the same, not so? So we said N1 is equal to M2. Why? Angles opposite equal sides. It's your radius. Okay. So we want to calculate N1. So I say N1 plus M2. But M2 is the same as N1. So I say 2N1. Why don't I go M2? Because I want to calculate N1. So twice into is 180 minus 70 degrees. Why? Sum of triangles. And it's triangle MON. Monday. No? Today is Monday. Right. So 180 divided minus 70 is 110 divided by 2. 55 degrees. There we go. 55. 55. Again, what do you note? I'm populating the diagram. Verstaan julle? Ja. Alright. So that's A uitgesort. Nee, A nie, né? A. Right. B. N2. How are you going to calculate N2? Sorry? First you're going to say that angle P is 90. Right, angle P is 90. Why? It's angle in semicircle. Now how are we going to calculate N2? Interior angles of triangle. Not so. So N2 is equal to 180 minus 90 minus 25. The reason? Sum of triangles. And it's triangle NLP. Okay. Now 180 minus 90 is 90 minus 25, 65. Is that correct? Right. Then they want you to calculate L1. L1. How are you going to calculate L1? Angle at center is twice angle at... Yes. So do your thing. Work it out. What do you having problems with? Girlfriend? What do you having problems? No, behind. She said she had a problem. Stop.
Good morning, may I have your attention please? Pride meeting will meet in room 17 now at break. Pride will meet in room 17 now at break. Is so Untitled, can you please report to the office for a collection? Is so Untitled to the office for a collection. Thank you.
Right, yes. Well, what was the issue? Yes. Sorry? But what do you notice about when I read through this, I fill in whatever I know. Whatever the story tells us, that's what I fill in. And that should help a lot. Okay, so start doing it like that. People, we see that angle at center is twice angle at circumference. Not so? So we're going to say that L1 is a half 70, which is 35 degrees. Reason, angle at center. Is twice angle equals 2 times angle at circumference. Okay? You all agree with that? Alright. People, the scope for the upcoming exam. Here we go. Who's writing? Let's put it in a group. Somebody must put it in a group. Firstly, you need to know the theorem. Both theorems. The proof of both theorems. Okay, that's worth 5 marks. Proof of both theorems is 5 marks. One of the two is coming. Yes. 5 or 6 marks. Yes. Now, you see the second theorem. Angle at center is twice angle at circumference. That's not the proof theorem. What we need to prove is by perpendicular from center by sextile. Remember when we drew and do construction? And angle at center is twice angle at circumference. That one is also a proof. Okay. Then geometry is basically 24 marks. Geometry is 24 marks. Then your equations, exponents, equations, and inequalities, that is worth so that's chapter 1 and chapter 2. That's including of nature of roots and all of those things. Okay? that is going to be the balance of the marks. So 25 marks on Euclidean geometry and the balance on chapter 1 and chapter 2, which is your simultaneous equations, your completing of the square, the application of your quadratic formula, the word problems, all of those things are going to come for 75 marks. Okay? Remember, on question 1 and 2, you will get an answer book, an answer sheet to write your answers on. However, the remaining questions, the algebra, will be written on normal folio paper. So what you do is you staple your answer book with your answer sheet. But your answer book is first, and then your line pages are off. Do you guys understand? People, for homework is the remainder of 9.3, the odd numbers. Enjoy the rest of your day. Good morning, class.